The method of drawing various geometric shapes with a pair of compasses and a straight edge or a ruler is known as construction. The ancient Greek mathematician Euclid made the first formal study of geometry, where he described methods of construction to produce figures when direct measurement could not be used. Let's review the construction of the bisector of an angle. We learnt this in previous classes. Here, we have an acute angle PQR. Taking Q as the center and any radius, draw an arc that intersects the rays QP and QR at points S and T respectively. Now, taking S and T as centers, draw two arcs of equal radius intersecting at a point X. The ray QX is the required bisector of the angle PQR. This means angle PQX equals angle RQX. Let's look at the construction of the perpendicular bisector of a line segment. Here we have a line segment LM. Taking L and M as centers and using the same radius, draw two arcs intersecting at point N above LM. Now, taking L and M as centers and using the same radius, draw two arcs intersecting at point O below LM. The line NO is the required perpendicular bisector of line segment LM, bisecting it at X. Here, NO is perpendicular to LM and LX equals XM. To construct an SSS triangle ABC, we choose any given side as a base. Now we cut the arc with a radius equal to the length of the other sides, with A and B as the center. The intersection of these two arcs gives us point C. Joining AC and BC will give us an SSS triangle. Division of a line segment in a ratio. To divide a line segment in a specified ratio without measuring the actual length, we will use the method discussed here, based on the theorem of proportionality and the concept of similar triangles. Let's see the steps to divide a line segment internally in the ratio P is to Q, where both P and Q are positive integers. Draw a line segment RS of given length using a ruler. Draw a ray RX at an acute angle to RS. Mark off P plus Q points with equal spaces between them along RX. The points will be R1, R2, R3, and RP, RP plus 1, and RP plus Q, such that R1 equals R1, R2 is equal to R2, R3, and so on. Join point S with point R, P plus Q. Through the point RP, draw a line parallel to RP plus Q, S, by making an angle equal to angle RP plus QS at RP. This line meets RS at a point P. Tap the buttons to understand this better with more examples.
Let's draw a line and divide it into the specified ratio. A rough figure gives us an idea of the line segment we have to draw and the ratio in which we have to divide it. Use the line tool to draw a line segment of length 8.5 units. Using the line tool, draw a ray making an acute angle with the line segment. If the ray was needed at a particular angle, say 60 degrees, we could have used the protractor tool. The ray extends beyond the visible area of the screen. To see objects beyond the visible area, use the scroll tool. Using the compass tool, draw arcs to mark 3 plus 2, that is, 5 equidistant points on the ray. Join the fifth point on the ray to the end point of the original line segment to complete a triangle. From the third point, make a ray parallel to the line segment just drawn to complete the triangle. Label the construction according to the requirements stated in the question. In this case, we label our original line segment AB and the point at which the ray intersects AB as D. Once you're done, tap the check button to validate your construction. Attempt this construction yourself. Attempt this construction yourself. Attempt this construction yourself. Attempt this construction yourself.
The scale factor is the ratio of the sides of the triangle to be drawn with the corresponding sides of the given triangle. If the scale factor is m by n, it means the sides of the triangle to be constructed are m by n times the length of the corresponding sides of the given triangle. Construction of a triangle similar to another triangle by a specified scale factor. There are two possibilities when constructing a triangle similar to a given triangle. Either the triangle to be drawn is smaller than the given triangle, that is, the scale factor is less than 1, or the triangle to be drawn is bigger than the given triangle, that is, the scale factor is greater than 1. Constructing a triangle smaller than the given triangle. Let's construct a triangle similar to the given triangle LMN with scale factor m by n, where m is less than n. Take any side of triangle LMN as the base. Here, let's take LM as the base of the triangle LMN. Draw acute angle MLX at the point L below the base LM. Mark off endpoints L1, L2, L3, Ln along the line Lx such that LL1 equals L1, L2 equals L2, L3 and so on up to Ln negative 1 Ln. Join LNM. From the point LM on Lx, draw LMM dash parallel to LMN that touches LM at M dash. Draw M dash N dash parallel to MN that touches LN at N dash. Triangle LM dash N dash is the required triangle similar to triangle LMN, whose sides are m by n times the corresponding sides of triangle LMN. Tap the button to understand this better with an example. Constructing a triangle bigger than the given triangle. Now, let's construct a triangle similar to the given triangle LMN with scale factor m by n. Take any side of triangle LMN as the base. Here, let's take LM as the base of triangle LMN. Draw acute angle MLX at the point L below the base LM. Mark off M points L1, L2, L3, Ln, Lm along the line Lx such that LL1 equals L1, L2 equals L2, L3 equals Lm negative 1 Lm. Join LNM. From the point LM on Lx, draw LM M dash parallel to LNM that touches the extension of LM at M dash. Draw M dash N dash parallel to MN that touches LN at N dash. Triangle LM dash N dash is the required triangle similar to triangle LMN, whose sides are m by n times the corresponding sides of triangle LMN. Tap the button to understand this better with an example.
Attempt this construction yourself. 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 Attempt this construction yourself.
Let's summarize what we have learnt in this topic. The tangent to a circle is a line which meets or intersects the circle at only one point. In this figure, LM is a tangent to the circle that touches the circle only at point P. There are three possibilities with regard to the number of tangents that can be drawn from a point depending on the position of the point. How to construct tangents to a circle? We know that there can be only one tangent through a point on a circle, called the point of contact. The tangent is always perpendicular to the line segment